This lesson is on inverse variation. So an inverse variation is a relationship that can be written in the form of y equals k over x, where k is a non-zero constant and x does not equal 0. And this is what we call an inverse variation. The constant k is the constant of the variation. So inverse variation applies that when one quantity will increase while the other quantity will decrease. So something to think about, the inverse or the opposite of something increasing. Now with working with inverse variation, we worked with direct variation last semester, and I just want to remind you, direct variation is an equation that can be written in the form of y equals k times x, where k is a non-zero constant. So the equations are pretty similar. With inverse variation, y equals k divided by x, whereas with direct variation, it's k times x, which is going to equal y. Here's a chart that kind of shows you how inverse variation works. So the words of this, y varies inversely as x. So y is inversely proportional to x. So if we were to plug in numbers, our constant, let's say k is going to be 3. So we take our constant divided by x, and then that would give us our y. Or if you multiply x times y, that's going to give you your constant k, which is 3. And then it also shows you the algebra as well. Please write this chart in your notes. So there are two methods to determine whether a relationship between data is an inverse variation. Here we have the function rule, y equals k divided by x form, or you can check whether x times y is a constant for each ordered pair. And we're going to look at some different methods here in a minute with some examples that we do. So here's our first example. They want us to tell whether each relationship is an inverse variation and then explain. So here we have a chart. We have our x values and our y values. And we want to our first step is we're going to write a function rule. So how did we get from x to y? Well, for the first table, it's going to be -2 times x is going to give me my y, because -12 times -2 gives me 24. 1 times -2 gives me -2, and 8 times -2 gives me -16. Is this function an inverse variation function? Well, it's not, because we cannot write this. We cannot write it in the inverse variation form of k over x equals y. So our answer for this is this relationship is not an inverse variation. Looking at the next one, we have our x's and y's. So my x is 3, y is 3, x is 9, y is 1, x is 18, and y is 0.5. So we need to find our function, write our rule, and our rule here is y equals 9 over x. So if you take 9 divided by our x, then you're going to get your y. And is that in the inverse variation form? It is. Our constant is 9. 9 divided by x is going to give me my y. So for this situation, this relationship is in an inverse variation form. For the next one, they want us to write and graph the inverse variation, in which y is a half and x equals 10. So my first step is we're going to find k, and in order to find k, we're going to multiply x times y, so 10 times half, which is going to give me 5, so my k value is 5. The next step is we're going to use the value of k, 5, to write an inverse variation equation. So if 5 is my constant, it's going to be 5 over x, which is going to give me my y. And then we're going to use the equation to make a table of values. So you can choose I would choose a few negatives and a few positives like I have here. So here I chose -4 for x, -2, -1, 0, 1, 2, and 4. And then I plugged in those values into the equation over here, 5 over x, to get my y's. So my y values, how did I get this? 5 divided by x to get your y. So 5 divided by -1 gives me -5. You cannot divide by 0, so that's why when you have x as 0 is undefined. And when we graph this here in a minute, you'll see what it looks like when we graph this. Again, if we plug in 1 for x, we're going to get 5 divided by 1 to get 5. And you can see in the table here how that's working out. So our last step for this problem is they want us to plot the points and connect them to create smooth curves. So this is what my graph is going to look like. Notice I have, it looks like two exponential graphs here. And where 0 is undefined, notice these graphs are not at any place on, it's like two separate curves. So it's like you're graphing the negative values and then you're graphing the positive values. So this graph represents this inverse variation. And then again at 0, when it says undefined, you're not connecting it anywhere, it's just nothing. So our last example in this section, they're giving us x1, which is 2, and y1, which is -6. They're giving us x2, which is -4. They're saying let y vary inversely as x, and they want us to find y2. So it's like they're giving us ordered pairs here, and they're wanting us to find my y2 value for the ordered pairs. So the first way I'm going to set this up is we set it x1 times y1 equals x2 times y2. So we're going to plug these values in. So my x1 is 2, my y1 is -6. And then my x2 is -4. So notice these values, we're going to set it up so that it's 2 times -6 equals -4 times y2. And this y2 is what we're solving for, what we need to figure out. So we're going to simplify this down. 2 times -6 is -12 equals -4 times y squared. So I'm now going to divide -4 to both sides. And -12 divided by -4 is going to give me +3. So my y2 equals 3. And that will be my answer for this example. And you'll see some like this in the bookwork that you do as well. So that's it for inverse variation. And you will be doing some more problems with this in class.